All right, so we do FOIL. We get 10 minus 15i plus 12i minus 18i squared. And then what? Combine like terms. What do you get when you combine like terms? 10 minus 3i plus 18. Why did that become plus 18? I squared is negative 1, so it's a negative and a negative. That makes it a positive. Final answer, 28 minus 3i. All right, today we're going to talk about complex numbers in trigonometric form. We're going to draw what's called the complex plane. So on the x-axis, we're going to have real numbers. 1, 2, 3, 4, negative 1, negative 2, negative 3. On the y-axis, we're going to have imaginary numbers. I, 2i, 3i, negative I, negative 2i, negative 3i. So how would you plot, say, 2 plus I? What do you think the graph of 2 plus I is? Well, 2 is the real part. So I start at the origin, and I go over 2. And then what do I do with this I? I go up to where the I is. So we would call that point right there. That would be the point 2 plus I. Bless you. How about the point negative 1 minus 3i? Where's the point negative 1 minus 3i? Go over negative 1 to the left and down 3i's. That's right. So it would be right about there, right where the dot is on my I. That would be negative 1 minus 3i. What's the absolute value of 5? 5. Good. What's the absolute value of negative 6? 6. What's the absolute value of 2 plus I?
2.
All right, so what does absolute value mean? All right, it just makes it positive. That's true, that's what it does. But it really means a distance from 0. So the absolute value of 5 is 5 because 5 is 5 units away from 0. And the absolute value of negative 6 is 6 units away from 0. How far is 2 plus I away from 0? That's what the absolute value of 2 plus I would mean. So how far away is it? No, it's not 2 plus I. It's a distance. A distance has to be a real number. Well, let me ask you a question. How far is this distance? 2. How far is that distance? 1. 1i. Its length is 1. If this distance is 1 and if this distance is 2 and that distance is 1, how would you find that distance? Pythagorean theorem. So what's the absolute value of 2 plus I? Not a nice number.
Square root of 3.
Bigger than square root of 3. Square root of 5. It would be the square root of 2 squared plus 1 squared, because this length is a distance of 1. So it's just a square root of 5. What's the absolute value of minus 1 minus 3i? It's going to be the square root of Well, again, we could draw our little triangle here. How far is this distance? It's really 1, but I'm going to write it as -1 squared, because if I square 1 or if I square -1, I get the same answer, don't I? Plus how long is this? -3, so I'm going to take -3 and square it. The absolute value of -1 minus 3i is the square root of 10. Questions on that? Okay. Now we're ready for some trigonometry. That right there, I just drew that point. That's the point a plus bi. If that's the point a plus bi, how far is that distance c? In terms of the letters a and b. That's the Pythagorean theorem, isn't it? This distance is a, this distance is b. So c squared is a squared plus b squared. So c is the square root of a squared plus b squared. We're going to call that angle theta right there. What can you tell me about that angle theta? How about, for example, what's the cosine of theta? What? A over c? And what's the sine of theta? B over c. Or I could say A is c cosine theta, and this one I could write as B equals c sine theta. Why is that so dark today? I don't know. Hard to see, isn't it? Okay. All right, so what we can do, a plus bi, I can write as a, we just said was c cosine theta, plus b, we just said is c sine theta. And then we got to multiply by the I, because we have b times I. So this is c times cosine theta plus I sine theta. And that's called trigonometric form of a complex number. Questions on how I got that? All right, so first thing we're going to do, 1 minus I. That's written in standard notation. I want you to take 1 minus I and write it in trigonometric notation. So in order to write it in trigonometric notation, you need to find two things. You need to find C, and you need to find angle theta. Finding C is pretty easy. What's C? C is square root of a squared plus b squared. So C is the square root of a squared plus b squared. What's A? A is 1. What's B? Notice b is just a number that's in front of the I. -1 actually, but it wouldn't really matter if you used 1. So it's 1 squared plus -1 squared, that's the square root of 2. C is the square root of 2. All right, now how are we going to find the angle theta? Maybe it would help if we drew a picture, all right? Where is the point, the complex point, 1 minus I? Right and down. So right 1, down 1. So this is 1 minus I. Let's draw my triangle. You just told me this was right 1, this was down 1, and we already figured out that distance. That distance is square root of 2. So right 1, that's a positive 1, down 1, -1. That length is square root of 2. I want to know the angle. What do I mean by the angle? Well, we really have two choices here. We could use this angle and write it as a negative answer, or we could use that angle and write it as a positive answer. Either one would work. Which one do you like? You like the positive answer or the negative answer? The negative answer. Okay, good. What's the negative answer?
45.
Why negative 45?
1 square root of 2 is one of the basic triangles.
1 square root of 2 is one of the basic triangles. Or you might say tangent of theta has to be opposite over adjacent. -1 over 1. So tangent of theta is -1. And we look on our chart that we've memorized. Tangent of what gives me -1? Or tangent of what gives me +1? Pi over 4 or 45 degrees. But we want the negative answer, so the answer would have to be -45. All right, so here's our answer. 1 minus I is the square root of 2 times cosine of -45 degrees plus I sine of -45 degrees. That's square root of 2 times, what's the cosine of -45 degrees? Close. It's not -√2 over 2. It's root 2 over 2. Because we're down here in quadrant 4, cosine is positive down here in quadrant 4. So it's square root of 2 over 2 plus I sine of -45. -√2 over 2. And then what would happen if I took the square root of 2 and distributed it in? What's the square root of 2 times the square root of 2 over 2?
1.
It's 1, because square root of 2 times square root of 2 is 2. Same thing here. Square root of 2 times square root of 2 is going to be 2. This is going to be reduced to 1. Notice it is the right answer because we would have 1 minus I. So asking for trigonometric form, we would write our answer that way. But I just wanted to show you that if I do the cosine and if I do the sine, I do get right back to where I started.
Did you foil the root 2?
Yep.
Both of them?
So yeah, because I would, the root 2 is out here, so I'd have to distribute it to both of them.
And the second part is it's not uniform.
It would be -1.
But
That's,
then I, so.
and then the negative I. Yep. Okay, so here's another point. How about square root of 3 plus I? Let's convert that to trig form. Again, I start by finding C. What would C be? Square root of? Square root of 3 squared plus 1 squared. Square root of 3 squared? 3 plus 1? Square root of 4? Turns out to be a real nice number. Turns out to be 2. All right, again, it might help to draw a picture here. So this is our triangle. This is the square root of 3. This is 1. That one we just determined to be 2. So there's my angle theta. Is that one of our special angles?
Yes.
Yes. What special angle does that happen to be?
30.
How do you know it's 30?
Well, sine of theta is 1/2.
Sine of theta would be opposite over hypotenuse. Sine of theta would be 1/2, and that is 30 degrees. You're absolutely right. So here again we have one of our special angles, 30 degrees. Our final answer would be square root of 3 plus I is, C is 2 times cosine of 30 degrees plus I sine of 30 degrees. Questions on that?
Do you leave it or do you just?
If the directions are write your answer in trigonometric form, that's it. Now, if you want to check, you could do cosine of 30 degrees, sine of 30 degrees, and then distribute that 2 through and see if you got the right answer. I'm pretty sure we do. All right, well, here's the big question. Why in the world would we want to take a complex number, square root of 3 plus I mean, that looks pretty simple to me. Why in the world would we want to take it and write it in trigonometric form in the first place? What's this good for? That's the obvious question. All right, here's the answer. What if I have 2 complex numbers? I'm going to write my 2 complex numbers as, I don't want to use the same letters over again. Well, here's what we did before. What if I give you 2 complex numbers written that way, a plus bi and c plus bi, and I ask you to multiply them? What do you have to do? You got to FOIL it all out. Remember that I squared is -1, and then combine all your like terms, right? Was that hard? Not too bad, right? FOILing isn't too bad. What if I ask you to divide complex numbers? Anybody remember how to take 2 plus 3i and divide by 5 minus I? Yeah, you got to multiply top and bottom by the conjugate. So you got to do FOIL on top, you got to do FOIL on bottom, you got to combine all your like terms and hope you didn't make an arithmetic mistake somewhere. Kind of a pain in the neck. What if I have R1 times cosine theta plus I sine theta, and I want to multiply that by R2 times cosine, I'll use beta I guess, plus I sine beta. What if I want to multiply the numbers and they're in complex form? Or I'm sorry, they're in trigonometric form. Well, the first thing I would do is I would switch order, and I would multiply the R1 times R2. What's R1 times R2? It's just R1, R2. How am I going to multiply these 2 parenthesis things? I'm going to have to FOIL. All right, so when I FOIL, I'm going to have cosine theta, cosine beta. Then I take this one and multiply it by that one. That's plus I cosine theta sine beta. Then I move to this one and I distribute it. That's going to be plus I sine theta cosine beta. And then the last 2 is going to be, I'm going to have an I times an I. I times I is going to give me -1, so that's going to be negative sine theta sine beta. Looks gruesome, but it's going to get a lot better. You watch this. This is R1, R2 times. I'm going to write this as cosine theta cosine beta minus sine theta sine beta. So I took this one and put them next to each other because neither of those had an I in them. And then I'm going to take the two that had the I in them and I'm going to put them together. I'm going to factor the I out. So I'm going to write this as plus I times cosine theta sine beta plus sine theta cosine beta. Still looks gruesome. But here's where it gets really, really good. This is R1, R2 times. This is one of our special trig identities. Anybody happen to recognize that one where you have cosine times cosine minus sine times sine? That one happens to be cosine theta plus beta. That's the identity for adding two angles together. If you have cosine of theta plus beta, you do cosine theta cosine beta minus sine theta sine beta. Plus I times. Anybody happen to recognize this one? We have cosine of one, sine of the other, and then it switches. Sine of the second, cosine of the first. That's the sine of theta plus beta formula. So here's the deal. If I have 6 times cosine 30 degrees plus I sine 30 degrees, and I want to multiply that by 4 cosine 60 degrees plus I sine 60 degrees, what this formula tells me to do. This formula tells me multiply these two numbers. What's 6 times 4? 24. Times, what do I do with my angles? Simplify them how? Oh no, that's way too hard. This formula tells me add the two angles together. So I take 30 and I add 60. What's 30 plus 60? 90. So that's cosine 90 degrees. Plus I sine of 90 degrees. If my angles are written, if my complex numbers are written in trig form, to multiply them, all you do is you multiply the numbers out front and you add the angles. You don't have to do any FOIL. You don't have to do any I squared is -1 stuff. That's all you do. Multiply the numbers, add the angles. Questions on that? How do you think you divide two complex numbers written in trig form? You divide the numbers and you subtract the angles. So multiplying and dividing in complex form is pretty easy. So if I had, I don't know, give me a number. Nobody has a number they like? 10, there's a number. Cosine of, give me your favorite angle. 45 degrees. Plus I sine 45 degrees. And I wanted to divide that by 2 cosine of, let's go 30 degrees, plus I sine 30 degrees. The answer would be 10 divided by 2 is 5. What do I do with my angles? Subtract them, so that's going to be cosine 15 degrees plus I sine 15 degrees, and there's my answer. So multiplying and dividing in complex form is very, very simple. And that's one of the big advantages of it. The other big advantage of complex form is exponents. What if I asked you to take 1 plus I and square it? What would you have to do? You have to do FOIL. All right. So that would be 1 plus 2I plus I squared. That would be 2I. Not too bad, right? What if I asked you to take 1 plus I and raise it to the 5th? What would you do? You tell me, no, I'm not going to do that. It's too hard. That's what you should tell me. That's what you should really do. How do you multiply numbers that are in complex form? If I want to take R cosine theta plus I sine theta and square that whole thing, how would you do that? Okay, or let's write it this way. I'm going to write it as R cosine theta plus I sine theta times R cosine theta plus I sine theta. According to what we just did, you multiply the numbers out front. What's R times R? R squared. And then what do you do with the angles? You add them. So you're going to have R squared cosine of 2 theta plus I sine 2 theta. Well, what if I was feeling really, really mean and I now change this to a 5th power? So I'm going to have this R cosine theta plus I sine theta written down 5 times. So you're going to end up with R to the 5th. And then you're going to have a cosine theta 5 times. So what are you going to end up with? Cosine of 5 theta. So if I want to take R cosine theta plus I sine theta and raise that whole thing to the 5th power, I take the number out front and I raise it to the 5th power. I take the angle and I multiply it by 5. Much, much easier. Okay, so let's take 1 plus I and raise it to the 5th power. 1 plus I to the 5th. If you asked me to take 1 plus I and raise it to the 5th power, I would first convert that to trig form. So C is the square root of a squared plus b squared, which is 1 squared plus 1 squared. C is the square root of 2. Draw my picture here. 1 plus I is right there, which means this is 1, this is 1, this is square root of 2. We should recognize as that is one of our fancy angles that happens to be 45 degrees. Theta is 45 degrees. So to take 1 plus I to the 5th, I'm going to write that as square root of 2 cosine of 45 degrees plus I sine 45 degrees, all to the 5th power. My answer is square root of 2 to the 5th times cosine of, I take 45 times 5. 45 times 5, calculator says that's 225 degrees. Plus I sine 225 degrees. And if I wanted to, I could write this as square root of 2 to the 5th times, what's the cosine of 225 degrees? Which quadrant is 225 degrees in? It's in quadrant 3. What can you tell me about cosine in quadrant 3?
Negative.
It's negative. What's the reference angle for 225 degrees? It is 45, because if I take 225 minus 180, I get 45. So what's the cosine of 225 degrees? Negative square root of 2 over 2. Plus I times, what's the sine of 225 degrees? Negative square root of 2 over 2. What's the square root of 2 to the 5th times the square root of 2?
2.
Not 2. Not 1 either. Not negative 2. Square root of 2 to the 5th times square root of 2 to the 1st. I would add my exponents. That's square root of 2 to the 6th. Not 2 to the 5th, but you're close. That's the square root of 2 squared cubed, because 2 times 3 would be 6. What's the square root of 2 squared? What's 2 cubed? 8. So, the square root of 2 to the 5th times square root of 2 is 8. 8 divided by 2 is 4. So this is negative 4 minus 4i. That's what you get when you take 1 plus I to the 5th. You get negative 4 minus 4i. One plus I raised to the 5th. Calculator gives me the same answer. How's the calculator doing it? It actually did it exactly the same way we did. The calculator actually converts it to trig form, does the trig, and then converts it back. All right, the last thing in this section is roots. I don't remember this formula. So if we have the nth roots of a complex number, or a real number, it actually works for real numbers too, is r to the 1 over n times cosine of theta over n plus k times 360 degrees over n plus I sine of the same thing. Sine of theta over n times k plus 360 over n. So, I've had people ask me this question before. I know that I is the square root of negative 1, but what's the square root of I? Kind of a weird question, right? What's the square root of I? Well, this would be I to the 1/2. So n is the number 2. N is 2 in this case. How many answers do we get? If you take the square root of something, how many answers are there? 2. There's usually one positive and one negative. So how many answers should we get here? 2. We'll get 2 answers. All right. First thing I'm going to do is I'm going to take I and I'm going to convert it to trigonometric form. So here's the point I right here. How long is that distance? That would be our C value. How far is that from the origin? That's 1. And what's our angle? 90 degrees. All right. So I in trig form is 1 times cosine 90 degrees plus I sine 90 degrees. So we can just write that as cosine 90 degrees plus I sine 90 degrees. All right, so I to the 1/2 is going to be my R number. My R number was 1, so I'm going to write it down. It would be 1 to the 1/2 times cosine of theta over n. Theta is 90 degrees, and n is 2 because we're doing square root. So that's going to be cosine of 90 over 2, which is of course 45, plus k times 360 divided by 2. Plus I sine of exactly the same thing, 90 over 2 plus k times 360 over 2. Now, what I haven't told you is what's that k thing? K is a constant. How many answers are we supposed to get? 2. So I'm going to plug 2 numbers in for k. What 2 numbers should I plug in? Nope. Easier than that. I'm going to plug in, if I need 2 answers, I'm going to plug in 0, and I'm going to plug in 1. If I was dealing with a cube root and I needed 3 answers, what numbers would I plug in? 0, 1, and 2. If I was dealing with a 10th root and I needed 10 answers, I would plug in 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so we plug in 0. K equals 0. So I to the 1/2 is cosine of 90 degrees divided by 2 is 45 degrees. And when I plug in 0 here, I'm just going to get 0. Plus I sine 45 degrees. So there's one of the square roots of I. And if we wanted to, we could write that as square root of 2 over 2 plus I square root of 2 over 2. So there's the square root of I. The other square root of I is I plug in k equals 1, and I'm going to have cosine of 45 degrees plus 360 divided by 2 is 180, and 180 times 1 is 180. Plus I sine, this will be the same thing, 45 plus 180. 45 plus 180 is 225 plus I sine 225. This one is negative square root of 2 over 2 minus I square root of 2 over 2. So notice, in a sense, we got one positive answer, one negative answer, but they're not really positive and negative because they're complex numbers, but you get the pattern. You get the positive things for A and B, and you get the negative things for A and B. So there's the square root of I. Now you know what the square root of I is. You always wanted to know that, didn't you?